Chapter 14 Basic Electricity and Electronics. Circuit diagram. Parts of a circuit. A circuit is made up of battery, bulb, and wires. What happens to circuits in series or parallel connection? In series connection, the current is same throughout the circuit. The total voltage of bulbs add up to supply voltage. If one bulb burns, whole circuit is broken and open. The other bulb stops working. In parallel connection, current is different from point to point in the circuit. Each bulb has the same rating as supply voltage. If one bulb burns, circuit is still closed for other bulbs and the bulb continues working. In this diagram, bulbs A and B are connected in series to one another, but bulb C is parallel to both bulbs A and B. As such, series properties apply to both bulbs A and B. Now consider bulbs A and B as a group. Parallel properties now apply to the group and bulb C. Switches. Switches make or break a circuit. When a switch is open, no current can flow through the circuit. Whereas, when a switch is closed, current can flow through the circuit. When the switch is open, it is an open circuit, so no current can flow through and the bulb does not light up. However, when the switch is closed, it will form a closed circuit and the current can flow through, so the bulb will light up. We have learned that in series circuit, the current will only flow when all the switches are closed. Series circuits are useful when it comes to household appliances like a microwave oven. The micro switch on door is in series with the main switch. It is safe to use because it will only work if both the main switch and the microwave door is closed. We have also learned that in a parallel circuit, current will flow when any of the switches are closed. This can be observed in the easy operation of the alarm switches of a bus, as pressing any switch on the bus will alert the bus driver. Now we will look at the types of switches. There are the SPST, single pole single throw, SPDT, single pole double throw, DPDT, double pole double throw. The simplest type of switch is the SPST switch. They have only two contacts and widely used everywhere like switches in your room. SPDT is a switch with three contacts. It has two output terminals. Closing the circuit with the first output terminal can cause a red lamp to light up, but closing the second output terminal will cause the green lamp to light up instead. DPDT switch is made up of two SPDT switches. It has 6 contacts. The pair of on-on switches operates together. Types of switches and their uses. The toggle switch is a simple on-off switch or selector switch. It is operated by a lever that can move between different positions. A rocker switch. Simple on-off switch. Rocks when it's pressed. Application: it is used on lamps. Next, we'll look at the slide switch. The slide switch is a simple on-off switch or selector switch. It is operated by slide movement. It is used in toys, radios, and torches. The push button switch. It is a standard on-off switch. Push once to switch on, push again to switch off. It is used on fans. Next, we will look at the press switch. The press switch is a momentary switch. It returns to normal off position when button is released. It is used on doorbells, keyboards, and calculators. The micro switch. It acts as a safety device to break contact. It is designed to switch open or closed in response to small movement. Application is used in washing machine, cookers, and microwave. The reed switch. It is used with a magnet. It is used in security sockets to check that doors are closed. Next is the tilt switch. It contains a ball of metal or mercury. When upright, metal bridges the contact inside and closes the switch. It is used as a sensor to detect the position of an object. Next, we have the membrane panel. It is thin with no moving parts and it's waterproof. It is used in keypads of cash dispensers and calculators. Output components in a circuit. Components that give off light and sound. A component that gives off light is a light bulb. It converts electrical energy to light energy. A component that gives off sound is the buzzer. It converts electrical energy to sound, and it is often used as a warning device. Components that create motion. One example is the motor. It converts electrical energy to kinetic energy, and it is used to turn wheels, gears, and pulleys. Next, we have the stepper motor. They are accurate motors as they can be made to turn through an exact number of steps. It is used in printers, scanners, and robotic devices. Components transferring energy. An electromagnet is simply a large coil of wire. Magnetic field created when end of wire connected to battery allows current to flow through the wire. More turns on the coil means stronger current flow, having greater magnetic field as a result. Next, we have the solenoid. It converts electrical energy to mechanical energy. Electromagnet inside activates the plunger. It is used in vending machines and arcade games. Finally, we have the relay. It allows low voltage circuit to switch on high voltage or high current circuits. Its safety purpose is to keep high voltage away from user switch. It is used in products that need high current, for example, in washing machines and electric ovens. Next, we have components that control current flow. An example will be the light-emitting diode. It converts electrical energy to light. It is more durable compared to a light bulb as it uses less energy. It is available in different colors. It is normally used in traffic lights and car rear lights. It has a flat edge known as a cathode, and it connects to a negative terminal. We have reached the summary of this chapter. We must know what happens to current and voltage when in series and parallel connections. In series, we note that the current is the same throughout the circuit. The total voltage of bulbs add up to supply voltage. If one bulb burns, whole circuit is broken and open. The other bulbs stop working as a result. In a parallel circuit, current is different from point to point in the circuit. Each bulb has same rating as supply voltage. If one bulb burns, circuit is still closed for the other bulbs and the bulbs continue working. Next, we have to understand the use of a switch. We must know, again, what happens when switches are connected in series and parallel, and we understand and know the various types of switches and their application. Next, we must understand and know the various output components such as those giving off light and sound, those creating motion, those that transfer energy, and finally, those that control the current flow. We have come to the end of this chapter.